Hi, good day. My name is William T. Dongo, your professor today. Today we will be discussing about the low pressure, low velocity duct system design consideration commercial type. And we will be discussing about section 4. The title of the lecture will be duct system pressure changes. From these duct pressure changes, we can calculate that the size of the pump CFM that you will be requiring. Pump selection requires knowledge of the total duct system pressure loss. Okay, the total duct system loss is equals to the sum of the total pressure losses that occurs across the various duct system components. Duct system pressure losses, the total pressure inside the duct always decreases in the direction of the flow. The decrease in the total pressure energy that is dissipated by the friction. The amount of pressure that is lost in the entire duct system equals to the sum of the pressure loss that occurs across the length of the various duct system components. Okay? The duct system components fall into 5 categories. Each component had a different procedures to estimate the pressure drop across a component. The 5 categories of the duct system are here. Duct system components, 5 general categories. The first one, we gotta have the straight section of the duct, the duct system fittings, okay, fan inlet and outlet fittings, air side devices, and then the supply outlet and return outlet. Okay, now the straight section of the duct. In the straight section of the duct, the velocity and velocity pressure are constant. The total pressure drop across the length of the section is equals to the static pressure drop across the length of the section. Condition. Now, repeat me. Consider the surface roughness of the duct material, altitude, and the temperature. Okay, that means you must consider the roughness of the duct, material used, altitude, and temperature. So just like as we know, we can use different materials depending on the use. So you can pick it up. Each materials will have different friction losses in there. And then we talk about the fitting pressure drops. Fittings pressure drops. 2 fittings subcategories. Okay, the fitting characteristic by velocity change. Okay, and then the fittings characterized by no velocity change. The one that have fittings characteristics by velocity changes, when velocities of the entrance and exit of the fittings are not equal, some static pressure is converted to velocity pressure or vice versa. Some example of this type of fittings are the transition between the straight section of different sizes, elbows with different entrance and exit areas, fittings with different entrance and exit velocities, and then inlet and outlet fittings. Okay, fittings characterized no velocity chart changes. Where velocity at the entrance and exit of the fittings are there is no change in velocity, pressure and decreasing to the pressure is equals to the decrease in static pressure. Okay, the pan inlet and outlet fittings. Pan inlet and pan outlet pressure drops, the fittings that are used to connect the fan to the supply and return duct, can have a very large influence on the duct fan system performance. Since velocity changes occurs at the fittings, the concept of equivalent length does not apply, and the loss should be described as the total pressure loss. Okay, now we're gonna talk about the airside devices. Airside devices produce a pressure drop. When devices is installed in the duct system, airways, it will produce a resistance in airflow, and there will be a pressure drop across the duct. Okay, so the different equipment that are supplied to the different airside devices that we put inside the system are are written in here, in which I will read them to you. They are the air distribution devices. We got air valve, okay, air valve, constant volume reheat. These are coils. Constant volume mixing, variable air volume VAV, variable air volume reheat, pan powered VAV, okay, and then dual duct mixing, and then induction mixing. And then the other one we have the one that we put inside the airstream is the air washer, and then inside there too we put air dampers. Okay, they can be in their dampers in open position. They will be a balancing, control, or smoke dampers. Duct system monitoring devices. That means we monitor the flow. That means flow measuring station, pressure measuring station. And then we put eliminator wet inside the system too. And then we put filters do inside the system, filter new and dirty. You got three filters, and then final filters. Filters can be a carbon filters or pleated filters. And then inside too, we put a heat exchanger, air-to-air energy recovery, indirect fire duct heaters, okay. And then another one we put in there too is heating and cooling coil. We can put a DX coil, that is dry and wet, water coil, dry and wet, steam coil, dry, and then electric heater coil, okay. And then we put inside there too a humidifier. Well, humidifier is the equipment that is used to maintain this moisture inside the air system, inside the room, meaning inside the room, because let's say it's a special room, just like a calibration shop or measuring, calibrating instrument, or the computer room. Make sure the clean room, make sure that all of those, the humidities, make sure it's right. And then we have another one here, the louvers end screen, okay. And then we got another one here, obstruction. We have static plate, pipes, leads, and then orifices. And then we have last one we categorize. We got a soundtrack. Okay, those are the airside devices that we will install into the system that will produce a friction. And then each one of these will produce a different type or different value in the friction it will produce. The friction that the pan-powered VAV will be different from the friction that it will produce by the balancing dampers. So there will be a table in which you gotta look at for the manufacturers of the equipment, on all this equipment here, it will tell you how much friction will be lost once it's past that particular component. Okay? And now we're going to talk about the supply outlet and the return outlet. Supply outlet and return inlet pressure drop. Velocity changes always occurs at supply outlet and return inlet. Therefore, the losses at this point should be categorized by the changes in the total pressure. Always refer to manufacturer's performance data for the information on the pressure drops is associated with any particular devices. Just like I mentioned, when you look at the technical manual on all of these, it will give you the pressure, the friction losses once the air passes through this equipment inside the duct. Duct system total pressure loss. Note 1. Total pressure of duct system is determined by subtracting the total pressure just before the fan inlet, which is negative, from the total pressure just after the outlet. The duct system total pressure loss, PT, is equal to the sum of the system losses. The duct system total pressure loss, PT, represent the exact amount of energy that is required to move air through the duct system. This means that when a fan is selected to deliver the described CFM, the fan total pressure PT must be equal to the duct system total pressure loss. Okay? And then we got a duct system total pressure drop is determined by the subtracting the static pressure just before the fan inlet, which is negative, from the static pressure just after the fan outlet. So as you see, so if you got a straight system that will have a fan and then a duct and directly dump the air into the room, so the only loss you're gonna have in there is the friction loss inside the duct and then the outlet on the fan. But if you put more of these components over here, as the air passes through it, there will be more friction. So just like it was mentioned, when you sizes the fan CFM, you gotta deduct all of this friction that you're gonna have inside the duct. Okay? Thank you. Next one, we're gonna talk about what are the other variables that be contributing to inside the duct system that will produce friction. We might discussing fittings, and then the way the fan are connected to the system. Okay, I thank you very much, and then I'm giving this lecture just for educational purposes only, and not for you to really use this as a code. If you need to do your coding, you make sure you use the CD code and the state code. Thank you very much. Bye.